It's time to start, but I don't see Alvaro yet, so I'm going to wait another minute or so. Or maybe not. Yeah. I just got advice to just go ahead, so that's what we'll do. So welcome to this Money meeting in the very last time slot of IETF 112. This is actually the second episode of the Don and Ron show. My co-chair Don Fedek is here to help me bring this to a somewhat successful end. There's a high probability that you have seen the note well before this week, but it's still important. So pay attention to it. And we've been asked, and you probably also have heard this, to especially point out the code of conduct and the anti-harassment rules. Don, do you want to say something about those?
No, that was it. I mean, like, unless anybody has a question, but you should have seen this by now.
Yeah, and I'm happy to say that I haven't seen any real bad behavior in the Money Working Group for quite a number of years. So keep it that way, and we won't have any of this trouble. Okay, this is some standard stuff which you also should have experienced by now. We have the Money Working Group. We have a general Money mailing list. We have a list specifically for reaching the chairs. Alvaro Ratana is our responsible AD. And we have an agenda for this meeting. The note will you have seen. We can bash the agenda if somebody wants to change anything. And we would like to have some people use the headstock tool to keep some notes. Next up will be the draft status for working group documents. We have an agenda item that we put on the agenda after some hesitation, because it's really something that we should resolve over the mailing list. But while we're here, we may spend a couple of minutes on this. Then we go to one draft that's still in the working group that should be ready for working group last call, unless somebody has serious objections. There are a couple of individual drafts by Henning Rogge, who is probably not here, but we have something to say about those. And then there's a very brief revisit of the future work agenda item, which we went into more extensively in IETF 111. And then I'm very glad to be able to announce that Ed Brain has agreed to present what's now known as the DTN Network Management Framework or architecture, formerly known as Asynchronous Management Architecture. And now the new name suggests that this is purely for DTN, but I hope that in his presentation it will become clear why this might also be relevant for our working group and how it might help us deal with one of our charter items. There are these 3 internet drafts which are centered around flow control and specifically diff server-aware credit-based flow control. They have been in the working group for a very long time. They went through a very long working group last call, not because there were so many comments, but because there were so few. They have now left the working group and they are under transport area. They're on a review of the early review of the transport area review team. Specifically, the review will be done by David Black, and we requested an end date of November 30th. But he has indicated that he may overrun that with a couple of days. But I don't know whether this will lead to extreme frustration with the authors. But yeah, given the long history, I would be inclined to think what difference do a couple of days make. So hopefully somewhere in early December we have the feedback from David. We will process that swiftly, I hope. Then the idea is that I would become a document shepherd, unless there's somebody who's very keen on taking that role. I've never done it before, but I'm prepared to do it, unless it has always been somebody's dream to do this. Let's see if there's anything in the chat. No. Then there's one remaining draft in the working group, which is really belongs to the same group of credit-based flow control extensions, but one that uses the 802.1q header as a distinguishing factor for flows instead of DSCP, like in DA credit. For some unclear reason, this one has gotten behind the other ones. It's also dependent on the traffic classification and general credit flow control documents. So the idea is to have a, let's say, 2-week, yeah, maybe 3 weeks working group last call, and then send it running behind the other documents that we have sent to the transport area review team. And then now I have already covered agenda item 4 practically. And on agenda item 5 is a discussion on these currently individual drafts by Henning Roga on physical layer DLAP extensions. So to this errata resolution, there was an erratum filed by Rick Taylor at the beginning of this year, because there was something in RC 8175, the main DLAP specification, where it said that when a discovery signal was answered by a modem, the IP addresses, source and destination, should be swapped. Unfortunately, for sending back the reply, the acceptance, Unfortunately, this destination address was a multicast address, so that wouldn't quite work. We have been trying to come up with better wording. At some point, that gets stalled. Our AD recognized the problem, but marked the erratum for also as held for document update. But now it's apparently being reopened, and recently Brian Citus said, yeah, wait a minute, but there's also something about the UDP port numbers. They should also be swapped. But we were already trying to take care of that when we were trying to address erratum 6472. So Rick came up with some words, Alvaro came up with some words, and so did I, but we never completely resolved it. But I think we should just try harder, because it should be possible to have some unambiguous text there, really. If somebody wants to help, welcome. If not, then I'm going to propose something on the mailing list. I had hoped to do that before this meeting, but I did not get around to it. So that's one of a number of apologies that I have to make. This is basically what I just said.
Rick
Oh, go ahead.
Thanks, Ronald. So I was going to put my name forward. I have some time in the next 2 weeks to work on that errata. Just in a very quick summary, the text as it currently stands is half wrong and half misleading when talking about replying to the multicast discovery packet. Not only is the response IP address incorrect, but also there's no mention of what to do with the UDP port. The fix should be very simple. It's just a matter of wordsmithing, and we should be able to close off all three of those errata. One of them, I think, might be a duplicate, but we should be able to fix all three of those. I'll put my name forwards. I've got some time starting from Tuesday next week to certainly work on that. So I'll make that commitment.
And with words that are also
that aren't misleading,
comprehensible to US English speakers.
Okay, I might even include a diagram.
Yeah, but you said some time back that we could not use the construction neither nor or neither nor.
That was to do with the DTN charter, but yeah, okay.
No, that was to do with this erratum.
Oh, okay, fine. I like my double negatives. Yeah. Okay.
Okay. Yeah, glad to help, by the way, and thank you. Alvaro?
Thanks, Ronald. So really quick, yeah, I marked those two erratas from Brian as duplicates, and he explained to me what I missed. So I already asked the RC editor to reopen 6472.
Yeah, I
know.
know.
So what I'm going to do is I'm going to add there the extra detail about the UDP port. So just so you guys know, held for document update means this is a valid errata. We just didn't agree on it, the exact text, right? For me to mark it verified, we need something that will actually show up as the actual text. So now in the tools, you can go look at the verified errata, which will actually show up in the document when you see it, right? So if we want that, that's perfect. I'll just keep this open until we agree on text. That again, when you go see it, it'll show the new text instead of the old one. So that would be great if everyone agrees on the specific wording that Rick is going to work on. So again, 6472 is the one we're going to work on. and you'll have all the details from what Brian added and the original stuff from Rick. Thanks.
Thank you. Yes, that clarifies it. Indeed, my aim is to come up with some good replacement text so that people that are consulting 8175 have a possibility to see how this actually should be implemented. And I think that should be possible. That's a goal that we should set ourselves.
Rick's back in the queue.
Oh.
Just a very quick comment from me. Interestingly, all the implementations I've seen actually do it right. So the intention is obviously fairly obvious to a developer who reads it, who says, oh, well, obviously you mean me to reply here, but obviously the wording has to be right. But the good news is I don't think this is going to break loads of implementations from the ones I've seen anyway.
No, but anything we can do to avoid the confusion is worth it, I think. Okay, I'm going to skip this because I just said that, unless somebody now jumps up to a virtual floor microphone and say no. So then I'll take it. I'll start a working group last call on the mailing list, and then you have an opportunity to still raise any issues that you see with this document. Then there are the physical layer related DLAP extensions written by Henning Roge. That's my second apology to Henning Roge, although he's not here. I should have followed up more after the previous IETF. He has updated 2 of the 3 drafts, and he has responded to my review comments made just before IETF 111. And somehow I managed to miss his comments to the mailing list. And this was mainly about the rationale for providing role parameters like busy time, RX time, TX time to the router. This is about the general utilization draft, by the way. Instead of having the modem provide a single value for general utilization. And he has argued that there is benefit of having the raw parameters provided to the router. I'm not fully convinced, but this is a discussion that we really should continue on the mailing list, and I should have done that. But having said that, it shouldn't be only my opinion. So if other people can contribute here, that would be highly appreciated. The radio band DLAP extension is currently expired, but can easily be revived. I think it's very short and simple. I'm going to ask Henning to do that, and I am inclined to put that on one up for working group adoption, because I do see some benefits to having this information about frequency and bandwidth myself. So I will issue an adoption call, and if people have objections, they can respond to that. And then there's the radio quality one. And I think even Henning himself has some doubts about the way that the information is is to be presented to the router. So yeah, I will probably also start a discussion on that one on the mailing list, and then hopefully those interested can contribute. I know that, for instance, Rick Taylor has already provided some comments back when they were first published in their first version early in the year. But I think we should, or I should follow up on this. Then I come to the last of my chair slides. So we're a bit ahead on the agenda, possibly, which is good, because that would mean that after Ed's presentation, there will be some time for discussion. So, future work. There was some...
We have Lou in the queue.
Oh. Go ahead, Lou.
I'm happy to wait to the end of the slide.
Oh.
I didn't mean to interrupt you. I was just getting queued for the end of the slide.
So it was for this slide and not for the previous one?
That's right.
Okay, good. During an interoperability event in June, where I was part and Henning as well, some problem was discovered with OLSR v2 routers restarting and then making an unlucky pick of some random some sequence number values that were supposed to be random, not the same every time that the router starts, leading to a problem that topology control information from that router was no longer accepted by its neighbors. There was some discussion on the list back in July, which brought in Christopher Dearlove, one of the main authors of OLSR v2. He is retired, but was interested in helping out. If we were to write an informational RFC, because the idea is that this can be fixed without making any actual changes to the protocol, but just by some smarter configuration. So this would probably have to be altered by Christoph, Henning, and whoever else feels confident to help. So I will bring that up on the mailing list. Then there was a presentation at the IETF 110 about the necessity or the benefits of having a DLAB clarifications and lessons learned ID. There was some discussion after that, in which we were actually determining that this should be standard stack. This presentation in IETF 110 was made by Lou and Rick, and they are both very busy. They simply don't have the cycles to start this off. So again, a question to other working group participants, if anybody would be interested in working on this. Don't have to step up right now. Can express your interest on the mailing list. Last time we talked about the fact that there was no ongoing work on some other charter items not related to DLAB. One of those is multicast, and the plan to produce a multicast forwarding information base. Rick Taylor came to the microphone and said, yes, well, there are a lot of vendor-specific proprietary multicast solutions in Mane's out there, and maybe there's really nothing to do anymore for the Mane working group. I've since come across one example of such a vendor solution, or a different, how do I say, yeah, it is a standard of sorts, but not an IETF standard, where this is dealt with below the IP layer, below the network layer, using some cooperative broadcasting technique. And there may be others out there. However, I'm returning to this in the next major bullet on non-charter items. The other charter item is management, and there I hope we can draw inspiration from the presentation that Ed's about to give. My personal pet subject, and also something I work on in my day job, is Federation of Heterogeneous Manes. What if you have Manes which have possibly also proprietary routing protocols, all different, and they have to work together. Imagine some disaster relief operation where different agencies are coming together, each with their own equipment and their own ad hoc routing protocols, and you want to connect them together. One way to do that would be to have some routing overlay protocol that they could all speak, and then they could connect to each other. And that could cover unicast as well as multicast, and then we are back to multicast. Even though the individual ad hoc networks may have their proprietary multicast solutions, they would fail to communicate if there's no way to make these talk to each other or exchange multicast routing information in some form. So maybe there is something there after all. And that's it. Lou, go ahead.
Hi. Yeah, sorry about jumping in early. I thought you weren't going to go through the detail. I thought you were just going to flip to the next slide. So on the routing overlay, I think there might be some interesting overlap with the raw working group, because if you have, I mean, they're focused on the deterministic service, but they have to solve the same routing overlay, where if you have multiple radio networks and you want to provide deterministic service across them, I think you have to first solve this routing overlay problem.
Ah, interesting. And is the raw working group writing up something about that, or
there's an architecture document on it. I think the architecture document has a lot of room for improvements. There was some discussion about starting up weekly or semi-weekly calls on the architecture. So if I stay tuned to the list, the raw working group list, probably good to join in there into that discussion.
Okay.
Thank you.
Yeah, thank you. I am subscribed to that list, by the way, but maybe also a suggestion for others who are interested in this. Rick?
I'm just going to add my +1 to Lou's comment. I'm one of the co-chairs of RAW, and there is a bit of overlap with Mane. I mean, we're looking at reusing DLEP within RAW, So yeah, the federation of heterogeneous radio networks is very much part of what we're trying to handle in RAW, looking at it from a deterministic perspective, but I think there's applicability to MANE, and we are really trying to increase the round trip time in terms of generating the documents for the core frameworks and architectures. So we're trying to hold some semi-formal interims to really try and make progress. So I suggest people add comments to the RAW list as well. There's some crossover. I'm just kind of publicizing RAW now, so I'll stop.
I guess you mean decrease the round trip time instead of increase.
Yes, of course. Yeah.
Okay. Abdul Salam, go ahead, please.
Regarding the this routing overlay in RAW, usually they have different use case than MANE. So it's interesting to check to see if it's applicable. Their solution to our scenario is the same. So it will be because actually, as you said, in heterogeneous networking or in the disaster, we have the role nodes and also the MANE moving around. So both of them are important to have this, let's say, a routing overlay using both networks is important as a heterogeneous networks, but still that there are some things to be added. MANE is different than LLN. This is my opinion. Thank you.
Yes. My thinking is that if there's a solution that works for RAW with the required determinism, then it will also work for MANE's probably, but not the other way around. Anyway, it's good for at least a number of people in the MANE working group to be aware of what's developing in RAW in this extent. So I encourage people to follow that. And with that, I think I
Time for
need to get the other slides. Ed.
Hey, how are you? Can you hear me?
I can hear you. I can see you, although you seem to be very far away.
Yes. The signal propagation is a bit longer because I'm representing DTN.
Okay.
So
the virtual floor is yours.
thank you, and thank you for presenting the slides for me. So
Yes.
I wanted to take just 20 minutes or so, and thank you so much for giving me this opportunity to talk about how we are trying to deal with the problem and the question of network management in DTNs. There are an awful lot of slides in this particular slide deck. This was a larger presentation. What I would like to do is try and go over roughly the first 10 to 12 of those to talk about the problem at large. And then for those who are interested, the material is posted in terms of a backup material and additional information. And I, of course, would be more than happy to talk at length about this with anyone who is interested. If we go to the next slide. We started looking at this problem really quite a long time ago. We did some early publication and research associated with what makes managing DTNs different. We looked at just generally what are the components of a management architecture. We looked at whether delays versus disruptions were the driving features. We tried to understand what sort of infrastructure information was helpful. And what we drove to was the concept of end-to-end closed loop control over systems in a delayed and disrupted environment is not going to get us what we need. And that maybe seems like an obvious observation to make now, But at the time, there was a lot of energy going into trying to make networks not be disrupted in the first place so that you didn't have to deal with that problem. If we accept that we needed more open loop control, and if we accepted that we had to have local autonomy and sort of a local management function separate from a remote management function, then it changed the tech transfer opportunities, and it changed where we looked for solutions. So then we started looking at autonomous fault protection schemes, mobile code, scripting. We looked a lot at spacecraft because they were dealing with this problem sooner than others. And we originally put this together as something called the Delay Tolerant Network Management Protocol. It was a product of the research group. It was a utility also being looked at and implemented by NASA. When it moved into the DTN working group, it was retermed asynchronous management to refer to the asynchronous nature of the transport, not necessarily the asynchronous nature of the management applications themselves. If we go to the next slide. When we started looking at this in terms of synchronous versus asynchronous, particularly from a transport perspective, we looked at some of the obvious things at the time: Simple Network Management Protocol, NetConf. There was an Armon MIB at the time. And those are things that we know are pull-based and session-based and don't work in the kinds of transport environments where we would otherwise see bundle protocol, bundle protocol version 6 at the time and version 7 now being deployed. But the observation here is that, and this is the work being undertaken in the DTN working group, is that there are new capabilities coming out of the ops area, RESTconf, updates to Yang push, and more. And these have added a kind of asynchronous operation where applications can, agents can choose to more intelligently push data. But it still doesn't solve for us the fundamental asynchronousness of the underlying transport protocol and how that drives us to more autonomy on the local node other than only filtering autonomy. So if we go to the next slide. So if we zoom all the way back and say, what does this look like in a very, very scaled environment? This is perhaps an extreme MANE, where we would say that we could have ground entry points separate from space-based relays, separate from landers. We really like talking about these particular problems using these kinds of examples, partly because these are real-world problems or perhaps real off-world problems that we're dealing with now. But additionally, it helps us reason about the problems in ways where we are not going to fall into a local minima of a solution that is not scalable. If a solution can work with these levels of propagation delay, and if they can work with these levels of disruption, then they will work for many cases of propagation delay and many frequent disruptions. So this is the management model that we have tagged as our hard problem to solve. And in that, we see a couple of things. Certainly a node A versus a node C, but intermediate nodes where you could have an intermediate machine-to-machine manager and agent relationship separate from an end-to-end node A to node C manager and agent relationship. And the idea that we would be able to have either in regions or enclaves or spheres of influence a machine-to-machine management area, a place where data fusion could happen, or a place where you could have regional management, that was a very powerful concept for us. Next slide, please. So with that, and using spacecraft as the sort of driving example, and understanding that we wanted to look more into autonomy and what was typically fault protection autonomy, we did exactly that. We looked at spacecraft fault management systems. They tend to be stimulus response systems focused on heritage implementations. And of course, because of the resource constrained nature of the compute environment, they had very deterministic processing. And this was a little different than what we see coming out of IETF, for example, the management in data centers, where there's a lot of standards and open source tools and much higher investments into common solutions to common problems, as opposed to on spacecraft, where you have bespoke solutions to very unique problems. At the time, and I understand that this slide is a little bit dated, but at the time, there was a little more immaturity in the asynchronousness and even in the push models, But even today, the overall autonomy that we need, for example, in data centers, is not quite the same as the autonomy we would like in these more challenged environments. When I say inefficient implementations and protocol layering, I solely mean there that as a function of financial efficiency, to reuse vendor products and to layer things in ways that fit in and allow for more agile mixing and matching of capabilities, we can tolerate very, very large protocol stacks and separate responsibilities in ways where we could see 5, 10 different protocol stacks together. On a typical spacecraft, they compress that because even the processing capability is not always there. So spacecraft are not looking at processing, XML or large amounts of XML data, as an example. Far closer to IoT than in a very resourced data center. And ultimately, we tried to answer the question, if we put these two worlds together, what does that overlap look like? And is that a new management capability for us? So if we then go to the next slide, our initial answer to that was we felt that we needed something different, and we wanted to describe it in a couple of different ways. The first was to take that original delay-tolerant network management protocol, DTNMP, and break it as renamed asynchronous management, and soon to be renamed again in the DTN working group. And we wanted to break it into 3 different statements. The first at the time was aspirational, what we would call sort of a manifesto of the needs of a very challenged environment that was written down and adopted by the DTN working group as the asynchronous management architecture. And there is a reference to that, the AMA-03. That is a working group item. It is being refreshed. It is being renamed, I believe, the delay tolerant network management architecture, to really focus in on the fact that we can't just call this asynchronous, because asynchronous doesn't capture the full richness of needed autonomy and functioning in these allochronic environments where things just don't exist in the network all at once and we have a very challenged experience. But aspirationally, there needs to be that problem statement and that overall architecture. Separate from that, the data model becomes very, very important, because the data model between a local agent and a local management function, separate from the relationship between a local management function and a remote manager, perhaps in a more resourced part of the network, we need to have a better and more reliable way of talking about the autonomy and the expression of behavior on the far side of the delay and the far side of the disruption. And so we term that the asynchronous management architecture management model, as expressed in the asynchronous management architecture application data model, or ADM. And this sort of advisory model allows us to build managed objects, and the graphic to the right shows what a few of those are: externally defined data, literals, operators, controls like remote procedure calls almost, and table data and custom reports and variables and so on. To us, this is an ecosystem. In some ways, the information here includes some things that we don't see in traditional management models, and it explicitly prevents or excludes other things that we sometimes see in traditional management models. And this was sort of the output of our system engineering around what we think is important in this space. And then finally, and perhaps even most simply, there was the to be able to encode these models very, very, very compactly using CBOR, but also structuring the messages and the model to entice a more compact encoding. So in the AMP, the asynchronous management protocol, we could, using the DTN ION reference implementation, say, please add a contact into a contact graph. And this is the nature of the contact, and it is strongly typed, and this is when it starts and tops and data rates and the node that it starts from and the node that it goes to. The entire command to accomplish that is about 26 bytes. And so being able to get those very, very, very compressed encodings is important to us for a variety of reasons. And one of those, of course, is from an atomic transaction nature, you want as many management commands and controls to be together in a payload at once. But the other is, in a challenge network, bandwidth can sometimes be at a premium. And you don't want to take 1,000 bytes to communicate something that otherwise you could send in 26 bytes. We have also had people look at this set of AMA, ADM, and AMP and the data model associated with it and want to run it between microcontrollers, between systems, because even there the efficiency and the smallness of the data sizes are motivating as well. So very, very compact is important to us as well. So then, if we go just one more, currently there are some internet drafts, there are personal drafts, and then there are working group adopted drafts associated with some of this. For the protocols that are of interest right now to the delay tolerant networking working group, such as the application data models, think the moral equivalent of Yang models or MIBS and SNMP. We have those for an AMA agent itself. We have it for the bundle protocol security protocol, LTP for ION, NASA's reference implementation of some of the DTN technologies. And then we are also working to define additionally other encodings and to bring in and understand how we interact better with Yang. We looked at building our ADMs, our application data models, using and specifying them in Yang. But at the time, we were not able to specify quite everything we needed to. And now that we have Yang 1.1, we think we're a little bit closer to being able to just represent our autonomy model in the Yang models. But that is an ongoing bit of work between the DTN working group and then obviously some working groups in the ops area. The next slide just has a couple of forward link references. And then I was going to stop here. There are a couple of additional slides in terms of what we think are important as part of that overall network management architecture. But in the interest of time, I just wanted to pause and see if there were any questions about what we've covered so far. Okay. Ron, how are we doing on time?
You have a good 10 minutes.
Excellent. So if we could then go forward again. If we poke a little more into what we think are important architectural components, we have laid things out in our initial architecture document in terms of service definitions and desirable properties of the system. From a service definition standpoint, we have to define management for us as more than the generation and communication of performance monitoring data. And this goes back to the observation that closed loop control end-to-end is just not going to work in the kind of environments that we operate in. We need local agents to be able to change their own configuration as we respond to local events without a remote manager in the loop. We obviously need to be able to generate reports, but we want to be able to generate reports either as a function of time or a function of local state. And we may generate reports even if we're not sure that someone is listening. That's a very typical thing to do, for example, in a spacecraft system where you may only check in with your spacecraft once a week. And when you do check in with the spacecraft as a function of when you can get dish time or deep space network time in general, then you want all of the data that was produced appropriately over time to come down with the appropriate timestamp so that you could forensically reconstruct what happened on the spacecraft while you weren't checking in. And we think that any sort of network management system needs to be able to operate in that way. The difference, of course, is that if you put that together with autonomous parameterized control, you don't want to simply generate performance report data and cache it on the managed node until it could be sent back to someone at a future time. You want to generate that data and then have a local management function operate off of that cache of data so that you can get local autonomous parameterized control while the remote manager is not connected to the system or is too far away from a propagation perspective. And then lastly, to make this to be able to use this system, not just within standard authentication between nodes in a network, you also need more fine-grained administration as to who is allowed to see what data and who is allowed to issue what controls, typically as a function of access control and role access control. So if those are the fundamental services larger than performance monitoring, the properties of how we would want to create that are also important. As we said before, the design of the system can either inhibit or entice more effective and efficient encodings, and the design of the autonomy model and the local autonomy engines that go off of those models either can lend themselves to more or less efficient or hardware accelerated implementation, easier or harder to secure by role execution, and then just more palatability in terms of what you would implement in a secure or operational or otherwise far away system. The first, obviously, is that the intelligent push of information is required here. We cannot simply ask, we cannot respond to pull requests from information. We need to determine what we need on the platform itself. We know that now. Minimizing message size is very, very big for us. And I mentioned this on the prior slide. If I can get a message out in 26 bytes instead of 1,000 bytes, I think we should be tuning our models to that reality. Because very, very tiny message sizes are enabling in many of the areas where we need this local autonomy as a function of the challenge of the network or the challenge of the environment. When we talk about absolute data identification, it is part of a network management system that we can unambiguously reference data. And of course, we can do that in all of our network management systems. However, if you combine absolute data identification with minimized message size, then the construction of that naming scheme, the URIs, the hierarchical nature of the naming trees, the ability to truncate and assign nicknames or encodings or enumerations of portions and nodes within a naming tree, all of that needs to be thought out very, very carefully. If we were to look, for example, at other things like, I believe, Yang SIDS, which is a terrific idea, it is good if we can support, say, 63-bit identifiers as hashes over some part of a naming tree. But if you want to run regular expressions against it and there's not a hierarchy behind it to compare different SIDs, then it becomes hard to do that, that kind of globular naming and reasoning about things. Custom data identification was also important to us, and the idea that you needed, in the context of a mission or an operational deployment, to be able to build custom reports, custom variables, custom other bits of reporting, rules, time-based rules, state-based rules. And you need to be able to name those as well, and those don't necessarily have to be globally unique if they exist within like a particular operator's namespace. And then lastly, of course, is the autonomous operation. If we go to the next slide, the general architecture is not dramatically different to accomplish this. We have agents and we have managers. We rely, again, based on minimizing message size, on pre-shared schemas and the ability to communicate that during periods of configuration. And our model does accept for the fact that there are times when you can share and you do have end-to-end connectivity, even if it's in a DTN and it's not contiguous, that eventually you can get a message from one side of the network to the other, that you can use that for configuration, as long as that configuration can then include the behaviors that need to be autonomously managed until the next time you get an opportunity for more configuration coming back. Next slide. And then sort of lastly, in some of the initial prototyping work that we had done, the application data model to this autonomy model is something that we model in JSON. We have also modeled, to the extent that Yang at the time could support some of the expressions that we needed, we also managed or modeled these in JSON. And then if we go one more slide, this becomes the autonomy model again that we model in JSON and in CBOR on the wire. And one more past that is just sort of an example of what that encoding might look like in JSON for the bundle protocol. And it sort of speaks to, if we go one more slide. Yes, if the reason I like to bring this kind of encoding up, and then I will pause here, is that we also tried to build our model around things that would prevent us from having to do back and forth exchanges between really a local agent and a remote manager, but also even a local agent and a local manager. And the idea behind this is in the second named item here, bundles by priority, where we have a piece of externally defined data, an unsigned integer that stands for bundles by priority. But this unsigned integer data value can take a parameter. And the parameter is a mask of the kind of information that you would like. And so this idea, there's some syntactic sugar built into our model to allow us to do associative lookups, almost like function calls with generation of even simple data types, to avoid having to say things like, what kind of information do you have, or how would you map that information? And then once we get it back, then making a second call to down select within that set of information. So just in general, that's a little bit of a history of the AMA. It's being picked up and rebranded as Delay Tolerant Network Management. It does still have an aspirational piece, which is the problem we're trying to solve. It has a data modeling piece. It has a set of encodings, content encodings, separate from what will eventually also be transport encodings. And the model has focused on trying to enable very deterministic autonomy without requiring building scripting languages and mobile code, because sometimes there are obviously security issues around deploying that, particularly in resource-constrained systems that you don't check up on quite so often. So if anyone is more interested in the details of this work, I would be happy to answer questions here or talk to people offline as we go.
Ed, thank you very much. People need to know that I only asked Ed to do this a couple of days ago, and he stepped up and agreed to do it. So a big thank you, Ed. And I think that this could be relevant to Manes also, because with our protocols we try to keep the network connected, but somehow the laws of physics get in the way sometimes. And if the distance is too great for your radio range, or there are obstacles, or there's jamming or whatever, then yeah, your MANA may easily break into 2 or more pieces. And I think that then this asynchronous management approach can help to have these fragments of the network sort of manage themselves with some guidance that has been preloaded into them, and they can phone home, so to speak, as soon as they can. But I would like to hear from other participants in this session if they have any comments or ideas. We have just a couple of minutes left. Not all at once, please.
Well, I was thinking that, do you think this applies back to non-delay networks too? Like, is there benefits that, looking at something in the extreme, but then say taking it back to regular networks? Is there something you see that you could also use?
Absolutely. So and a lot of some of the additional asynchronous behavior that we're seeing coming out of ops area is the observation that just sending everything back to a common central management place is difficult and generates way too much traffic in well-resourced networks, because of course the data is scaling. The next part of that is, if you're able to filter what you choose to push, then you can also start tolerating operating in different transport environments. And so all the way down to microscale, we have microprocessors that would say, instead of using something like RMAP, there are times when our processor is just literally turned off, and another, say, a managing processor is turned off and then turns back on again. And wouldn't it be nice to be able to have these communications? And that's all on a single embedded platform. So we're not quite talking about delays and disruptions in that particular way. But the other is, if you want asynchronous behavior without requiring TLS sessions, for example, this is a good way of saying that if my 2 nodes are otherwise resourced, but they are turned off, and when they come up, they do have good ability to communicate with one another. The real benefit here is to be able to quickly synchronize on what autonomous actions did you take when I disconnected from you, or when I didn't have a session with you. And if you're able to have that behavior, you can then start building in the fact that you don't need the infrastructure and the cost and the expense to always maintain those sessions or reestablish those sessions. And so the amount of time that your remote manager actually has to be online can be reduced, even if otherwise you could choose the expense to always have it online. And we think that there are cost savings there without sacrificing the responsiveness of the managed device.
Thank you.
And with that, I think we're out of time. There's one other thing that I forgot to mention at the beginning of the meeting, is that Alvaro made me aware of a presentation yesterday that I missed on low Earth orbiting satellites and the potential routing problems that they may have in those networks. And unfortunately, I did not have the time to work through the draft that was produced there and presented. But I'm going to be in contact. I see that at least someone from the group was attending, Lin Han. So I hope to be able to have a chat in the near future. And in fact, I'm going to go into Gather after this meeting. And if anybody wants to talk, yeah, please do. And yeah, we're already 1 minute over, so I expect this session to end soon. Don, anything from you?
We do have a participant in the queue.
Oh, Abdul Salam.
Yeah,
Make it very quick.
Yeah, the low orbit satellite. I think it was a research group talking about this routing in the low orbit satellite. Yeah, I think it was a research. It's a research group actually. Is it?
I see here routing working group.
No, it's a research group. It's not the IETF working group. It's a IETFR researching group. They were talking about low orbit routing. I'm not sure, but if it was a IETF working group, please tell us which, or if the director already knows that, if he can put it on the list so we can check.
If you look in the chat, people are saying it was in the routing working group. But it could be also in the IETF, because it is a popular topic, I guess. And there was also last year a very good presentation on this in the Applied Networking Research Prize presentations. Okay, well, thank you very much for your attendance. Thank you to the people of MeetEcho who helped me out at the beginning of the session, and for providing MeetEcho in the first place, of course. And hope to see you all, whether online or maybe in person even, at the next IETF.
Yeah, thank you all.
Thanks. And as I've seen other chairs do, I just stare blankly until we're closed.
Well, people are either just waking up and logging out, or they'll just time out.
Yeah, I think. Bye.
So I had a suggestion. We should find a sexy logo for the group.
Yes, Sorry, I did not respond to that.
No, that's fine.
Now with this all the satellite stuff, maybe you should change your airplane to a satellite.
Yeah, I was thinking about that, but it was actually very simple to do. I saw an example of that. And
Okay.
so it only took about 15 minutes to do that.
Good.
All right. I'll see you next time.
Yep.
And on the list.
Yeah, certainly. I have a number of actions.
Okay. So there are some notes that should be available too. So
I will download those. Yes.